You are standing in front of a pile of dirt. Not special dirt, not imported materials, just the ground beneath your feet, dug up, mixed with water. In 3 months, this dirt will be a house. It will have walls thick enough to stop the heat, a roof that sheds rain, a floor that stays dry. It will shelter a family for 20 years or more if it is maintained. And it will cost almost nothing in terms of money, because money is not what builds it. Labor builds it. Knowledge builds it. The willingness to spend weeks shaping mud into walls, cutting grass into bundles, splitting trees into beams, all of this builds it. You cannot go to a store and buy a house. You cannot hire a construction company. There is no lumber yard, no concrete supplier, no hardware store. There is only what exists here: clay, sand, stone, wood, grass, water, and the understanding, passed down through generations, of how to take these materials and make them into shelter that works. For thousands of years, people across Africa have built homes entirely from materials available within walking distance of where they live. No manufactured products, no steel. No cement unless you count lime made from burned shells or stones. No glass, no plastic, no power tools. Everything is gathered by hand, processed by hand, assembled by hand. The houses that result are not primitive. They are sophisticated responses to specific environments. They solve problems. They keep people cool in heat, dry in rain, safe from wind and animals. They do this using materials that most modern builders would consider inadequate. But they work. They have always worked. And understanding how they work reveals just how much we have forgotten about building. Start with the foundation, because even a mud house needs a base. The site is chosen carefully, not in a low area where water pools during rain, not directly in the path of prevailing winds, not too close to large trees whose roots will undermine the walls, not on ground that is too sandy or too rocky. The ideal site is slightly elevated, with good drainage, with soil that has enough clay to bind, but not so much that it cracks badly when dry. The ground is cleared, vegetation is removed, stones are dug out, the soil is leveled as much as possible. In some traditions, a shallow trench is dug where the walls will stand. This trench is filled with stones if stones are available. The stones create a barrier between the mud walls and the ground. They prevent moisture from wicking up into the wall base, which would weaken it. Where stones are not available, the first layer of wall is built thicker and allowed to harden before the rest is added. The walls themselves are made from earth. The specific technique varies by region, by soil type, by cultural tradition, but the principle is the same. You take soil, add water, mix it until it reaches the right consistency, then form it into a wall. The simplest method is to build the wall up in layers. Wet mud is shaped by hand into a band around the perimeter, about 6 inches to a foot high. This layer is left to dry for a day or several days depending on the weather. Then another layer is added on top. Then another. You build slowly, allowing each layer to cure before adding weight above it. The mud mixture is not just dirt and water, it is engineered. Clay provides binding. Sand provides structure and reduces cracking. Plant fibers, straw, grass, animal dung, these are added to give tensile strength. Clay alone shrinks and cracks as it dries. Sand alone does not bind. The right mixture balances these properties. Too much clay and the walls crack. Too much sand and they crumble. The proportions are learned through experience. An experienced builder can feel the mud in their hands and know if it is right. In some regions, bricks are made instead of building walls directly from wet mud. Mud is mixed to the right consistency, packed into a wooden mold, smoothed on top, then turned out onto the ground to dry. The bricks dry in the sun for days or weeks. When they are hard, they are stacked to form walls. The bricks are mortared together with the same mud mixture they were made from. Brick building allows more precision. The walls can be straighter, the bricks can be made during the dry season and stored. Then the building can happen later. Some bricks are fired. A kiln is built, bricks are stacked inside with space between them, and a fire is lit beneath. The fire burns for days, heating the bricks until they harden permanently. Fired bricks are stronger, more water-resistant, longer-lasting, but firing requires a huge amount of fuel. Wood must be gathered or purchased. The process is labor-intensive. So fired bricks are used for important buildings, for structures meant to last generations. Most homes use unfired sun-dried bricks or wet-built walls. The walls are thick, 1 foot, 2 feet, sometimes more. Thickness is not waste, it is insulation. Thick walls stabilize temperature, as we have discussed. They also provide structural strength. A thin mud wall cracks and collapses easily. A thick wall is stable. The thickness also creates depth for window and door openings, which can be shaped and reinforced. As the walls rise, openings are left for doors and windows. A wooden frame is placed in the opening to support the mud above it. The wood might be a straight branch, stripped of bark, or a plank, if sawing is possible. The frame is embedded in the wall as it is built. Once the wall is complete, the frame stays in place permanently. Windows are small. Large windows weaken walls and let in too much heat or cold depending on the climate. Small windows provide light and ventilation without compromising the structure. In very hot regions, windows are placed high on walls to let hot air escape while keeping the living space cooler. In rainy regions, windows are minimal to prevent water intrusion. Doors are made from wood. Planks are cut or split from trees, fitted together and attached to a wooden frame with wooden pegs or leather hinges if metal is not available. Where metal is available through trade, metal hinges and latches are used. The door must fit the opening snugly to keep out wind, rain, and animals, but it must also be removable for repairs. The roof is a separate system. It must be strong enough to support its own weight and resist wind. It must shed water. It must insulate. The most common roof in many regions is thatch. Grass, reeds, palm fronds, any locally available plant material that is flexible when fresh and hardens when dry. The grass is cut during the dry season when it is fully mature. It is bundled and tied. The bundles are stacked to dry completely. The roof structure begins with beams. Trees are cut, stripped of branches, and shaped roughly. These beams span from wall to wall. In a rectangular house, beams run across the shorter dimension. The beams rest on top of the walls, embedded in the mud as the walls are finished, or laid in place after. They bear the weight of the roof. The size and number of beams depends on the span. A small house might have 3 or 4 beams. A larger house needs more. On top of the beams, smaller poles are laid perpendicular. These create a grid. Then the thatch is tied to this framework. Bundles of grass are laid starting from the bottom edge of the roof and working upward. Each layer overlaps the one below, like shingles. The grass is tied in place with twine made from plant fibers or strips of bark. The tying is meticulous. If the grass is not secured properly, wind will lift it, rain will penetrate. A thatched roof can be a foot thick or more. This thickness provides insulation and ensures that water runs off before penetrating to the interior. The grass is laid at an angle, creating a slope. Water hits the roof and flows down and off. The steeper the pitch, the faster water sheds. In regions with heavy rain, roofs are steeply pitched. In drier areas, they can be shallower. The peak of the roof is the most vulnerable point. This is where 2 sloping sides meet. It must be sealed carefully. Extra bundles of grass are tied over the peak, weighted down sometimes with poles or stones. If the peak leaks, water runs down the inside of the walls and damages them. Maintenance is constant. Thatch degrades. Grass rots, especially in humid climates. Insects nest in it. Birds pull it out for nesting material. Every year, the roof must be inspected. Damaged sections are replaced. New bundles are tied over thin spots. A well-maintained thatched roof lasts 5 to 10 years. A neglected one fails in 2 or 3. Some roofs are made from wood. Planks or split logs are laid overlapping like shingles. This is more durable than thatch, but requires more wood and more labor to produce. Wooden roofs are heavier and require stronger walls and beams. They are used where trees are abundant and where thatch materials are scarce. In regions with specific clays, roofs are sometimes made from mud. A framework of poles supports layers of mud built up thick enough to be waterproof. Flat mud roofs are common in very dry climates where rain is rare and light. The mud is packed hard and smooth. It is sloped slightly to drain the occasional rain. Mud roofs are heavy. They require very thick walls to support them. but they are excellent insulators and they last decades if maintained. The floor is earth. The ground inside the house is cleared, leveled, and compacted. In some traditions, a mixture of clay and water is spread over the floor and smoothed by hand, then left to dry into a hard surface. This surface is easier to keep clean than bare dirt. It does not produce dust. It can be swept. In wetter climates, floors are sometimes raised. A platform of poles and split wood is built above the ground level. This keeps the living space dry even if water pools outside. Raised floors also provide ventilation underneath, which reduces humidity and discourages insects and snakes. The walls, once built and dried, are often plastered. A thin layer of fine clay or mud is spread over the surface and smoothed. This seals small cracks, creates a smoother finish, and makes the walls easier to clean. Some plasters include dung, which adds binding strength and a smooth texture. The smell fades after drying. The result is a wall that is hard and slightly polished. Decoration happens in the plaster. Patterns are carved or molded while the plaster is still wet. Colors are added using natural pigments: white from kaolin clay or lime, red and yellow from ochre, black from charcoal. These pigments are mixed with water and painted onto the walls. The patterns are cultural, specific to the region or ethnic group. They identify the home. They beautify it. But they also serve a function. Light-colored plaster reflects heat. Patterns can mark the home's ownership or status. Interior walls divide the house into rooms. Not always. Small homes are often single rooms. Larger homes have partitions. These are built the same way as exterior walls, but thinner. They do not need to resist weather, only to provide privacy and separate functions. Sleeping areas, storage areas, cooking areas, if cooking happens inside. Cooking is often done outside or in a separate structure, a kitchen building, or a covered area in a courtyard. This keeps smoke and heat out of the sleeping areas. The kitchen structure is simpler, sometimes just a roof on posts with no walls, or walls on 3 sides open to allow smoke to escape. Storage is built into the design. Raised platforms inside the house keep stored grain or goods off the floor, away from moisture and rodents. Niches are shaped into the walls while they are being built. These alcoves hold lamps, utensils, personal items. Shelves are created by embedding poles into the walls and laying planks across them. Ventilation is managed through openings. Small gaps near the roof peak allow hot air to escape. Low openings or gaps in the walls allow cooler air to enter. This creates airflow without large windows. In some designs, decorative patterns in the plaster include small holes that allow air to pass while maintaining privacy and structural integrity. Security is considered. Doors are made to close firmly. Some have internal bars that slide into place. Windows are small enough that a person cannot climb through easily. In regions where theft or conflict is a concern, compounds are built. Multiple structures are arranged around a central courtyard with a single entrance that can be secured. The compound wall is built from the same mud as the houses. It encloses the family's space. Animal shelters are part of the complex. Goats, chickens, sheep, these are kept near the home at night for security. Small structures, simpler than the houses, but built from the same materials, provide shelter for animals. These keep the animals dry, protect them from predators, and keep them close. The labor of building is communal. A family does not build alone. Extended family helps. Neighbors help. This is expected and reciprocal. You help build your neighbor's house, and they help build yours. The work happens during the dry season when the weather is stable and when agricultural demands are lower. Building in the rainy season is nearly impossible. Mud does not dry. Materials are hard to transport. Work is miserable. A house might take weeks or months to complete, depending on its size and the number of people working. The work is hard. Digging clay, carrying water, mixing mud, shaping walls, cutting grass, assembling the roof. All of this is physical labor, but it is also social. People work together. They talk. They sing. Meals are shared. The building becomes a community event. Women often do the plastering and decorating. Men often do the heavy structural work, the roof framing, the large beam placement, but roles vary by culture. In some societies, women build the entire house. In others, it is men's work. Children help with tasks appropriate to their size and strength, carrying water, gathering materials, smoothing plaster. Knowledge is passed down through participation. A child helps build houses from a young age. By the time they are adults, they have built many houses. They know the process. They know how to judge mud consistency. They know how thick walls need to be. They know how to tie thatch. They know what mistakes look like and how to avoid them. This education is practical, continuous, and effective. Repairs are ongoing. Mud walls erode in rain. Corners round off. Surfaces need replastering every year or two. Roofs need maintenance. Floors need resurfacing. A house is not built and then forgotten. It is a living structure that requires care. Neglect leads to collapse. Attention leads to longevity. When a house fails, when walls crack beyond repair, or a roof collapses, the materials are often reused. Good bricks can be salvaged. Roof beams can be used again. Nothing is wasted. The site is cleared and a new house is built, often in the same location, using materials from the old house plus new materials gathered. The environmental impact is minimal. All materials are local. No transportation beyond human or animal labor. No industrial processing. No emissions. When the house is no longer needed, it dissolves back into the earth. There is no demolition waste. The materials came from the ground and returned to it. The houses are appropriate to their environment. In hot, dry climates, thick mud walls and small windows keep interiors cool. In humid climates, raised floors and large roof overhangs keep moisture out. In windy areas, low profiles and rounded shapes reduce wind resistance. In areas with termites, certain woods are avoided, or walls are built from materials termites cannot eat. The design responds to local challenges. What is striking is the self-sufficiency. A community can build everything it needs without importing anything. As long as there is suitable soil, wood for beams, and grass for roofing, shelter is possible. There is no dependency on supply chains, on manufacturers, on money beyond what might be needed for metal hinges or tools. But the system requires knowledge. If that knowledge is lost, if no one remembers how to mix mud properly, how to tie a roof, how to judge when a wall is dry enough for the next layer, then the system collapses. People become dependent on imported materials, on contractors, on money they might not have. The shift from traditional building to modern materials often happens quickly when roads arrive, when cement becomes available, when corrugated metal roofing is introduced. Sometimes, modern materials are better. Metal roofing lasts longer than thatch and requires less maintenance. Cement blocks are stronger than mud bricks, but sometimes they are worse. Metal roofing turns houses into ovens in hot climates and less insulated, which requires more money. Cement blocks are expensive and require skill to use properly. Poorly built modern houses can be worse than well-built traditional ones. What is often lost is the knowledge that building is possible without money, that materials exist all around, that labor and cooperation can create shelter. This knowledge made humans adaptable, made survival possible in any environment. Its loss makes people vulnerable, dependent, unable to provide for themselves. But in many places, the knowledge persists. Houses are still built from mud and thatch. Families still gather to help each other build. Children still learn by doing. The houses still stand. They still shelter. They still work. And when you watch it being built from literally nothing but dirt and grass and water, when you see the walls rise and the roof take shape and the family move in, you realize that shelter is not something that requires industrial civilization. It requires knowledge, labor, and community. Everything else is optional. You wonder if we could do it, if we had to, if the supply chains broke and the stores closed and we had only what was around us, whether we would know how to build, whether we would know what to do with dirt and grass, whether anyone taught us. They know. They still build. They take the earth beneath their feet and turn it into walls. They take grass from the field and turn it into a roof. They create homes from nothing, from materials we would walk past without seeing, from things we would call worthless. And they will keep building, as long as there is earth and grass and people who remember how. That is enough. It has always been enough.